Friends, today we are going to discuss one important activity where thermal spray is done, and in on the surface where powder, wire, or wrought material are melted or heated and then propelled at high velocity onto a component. It primarily used to enhance the wear resistance and corrosion resistance, and provide thermal insulation and repair or remanufacture damaged mechanical components. So when suppose your one shaft has damaged or erosion has take place, so replacing the full shaft will very costly. So you can do there you can apply there the thermal spray technology, and the property of the material will be remain more or less hardness, and wear resistance will be more or less the same or higher than the parent material, and you can save a lot of expenses to replace the complete shaft. So this the common mainly the the methods we are using in the industry. Primarily, there are three categories. That is called the high velocity oxygen fuel (HVOF), which uses high pressure combustion to spray dense, extremely hard coatings for wear or erosion resistance. Suppose shaft where your particularly for your where mechanical seal or oil seals are used, they are continuous rubbing or rubbing is there, their material will be eroded, then leakage will take place. So instead of replacing whole shaft, you can do this repair and you will get the strength of the and hardness of the material as per your as per the strength of your material of construction, MOC of the parent material. Then plasma. Also, you can use plasma. What is plasma? Now, a superheated gas with charged particles. Plasma spray is also a technique. Then uses high temperature plasma jet, ideal for applying high melting point ceramics. We are multiple ceramics and thermal barrier coating. Thermal barrier coating, where thermal barrier coating we can use. They are due to the high temperature, the melting deformation take place. But if you using this coating, then it can withstand more temperature than the more temperature than which cannot not possible with the normal steel. And then wear arc spray, the melt two consumables wares in an electrical arc, typically utilized for large scale corrosion protection. If the corrosion is there you can use this wear arc spray, and that will save the material from any external corrosion. So these are the mainly three category of spray we are doing. We are using. We normally choose for spray technology to safeguard and to your avoid purchase new material and remanufacture the damaged portion of an item. Now, after this coating, you see after the coating, you see these are the coating procedure. Here, you see there are yellow coatings we have applied. So then the surface will be slightly rough. So if you are using any O-ring etc. in the particularly portion, it will due to rubbing the O-ring will damage. So you need to be need to be grinded. So we are using diamond grinding wheels, and you will get a mirror finish. Yeah, tremendous mirror finish, and then you can use oil seal on O-ring etc. You can use, there will be no problem. So after this coating job is over, you have to do the grinding operation. Then the we have tell you the major three process. Then these three process can be again can be subdivided into another five. That is called the high velocity oxy fuel spray. That is the prime technology. Then there is another one technology. In addition to it, with slight deviation, you can say that is a combustion flame spraying. Then plasma spray. Then another one slightly deviation, that is called vacuum plasma spraying, and two were electric arc spraying. These are the process with which we are doing the spraying operation on the damaged portion to revive its life of the equipment. Now first we will discuss about the high velocity oxy fuel spraying, HVOF, high velocity oxy fuel spraying. What is this? Technology perform exceptionally well. It performs exceptionally well, delivering ultra dense, high strength, wear resistance coating by accelerating melted powder particles to supersonic speed. The speed of this jet will be supersonic, that is called 400 to 800 meter per second. The fuel gas such as propane, here they are using fuel gas. In this fuel gas, you see the fuel gas normally using propane or natural gas mixed with oxygen. Here mixed with oxygen mixed with oxygen in a combustion chamber. This one is called the combustion chamber. This one is a combustion chamber, and the mixture is ignited to create a high pressure, high temperature jet flame, that is 2000 to 300 degrees centigrade. And despite being thin, the coating will be thin, but the coating is very strong. It will very strongly adhere to the surface, to the well, and its resistance to corrosion is better than the plasma one. Its resistance to corrosion is better than the plasma one. So where what you are using, now you see here you are using the annular space. Here we are using annular annular space is there, that is called here fuel gas. Fuel gas means either propane or natural gas, and then oxygen mixture we are inserting from this inner. We are inserting powder or carrier gas. To powder or carrier gas will go, and then outside air will go, and then ignition will take place here, and then high jet velocity at around 400 to 800 meter per second, this jet will go, and it will stuck on the surface of the substrate, and the coating will be applied. You see, the coating will be applied. But to get better result, you have to do the surface cleaning before this operation. You need to do the cleaning of the substrate. That is how now you have to either do the short blasting or grid blasting, then degreasing, then masking, and your surface roughness shall be 3 to 8 micron roughness. That if you get the surface, then your adhere of this powder will be on the surface, and that will give you wear resistance coating, and there will not be better than the parent material. Then combustion flame spraying. Flame spraying is also the similar process, but it is not strongly attached to the surface, since the spray mechanism powder by a lower flame velocity. There earlier we have seen the velocity where how much, now 400 to 800 meter per second. Here the spray velocity will be less, slightly less. That's why the adherence to the surface with the substrate will be slightly less. But if it is low cost, it is low cost also. The low intensity application due to its low cost, when this much adherence, this much wear resistance is not required, or not adherence is not so important. So you can use this technology where the technology where flame velocity will be less. You see here also the carrier gas, powder gas will be there. Powder are mixing afterwards in your HVAC. Powder and gas are mixed together and then inserted. But here powder separately, then carrier gas is there, and then oxygen and fuel will be there. Then oxygen fuel will be there, and then nozzle, it will be ignited, and it will be, velocity will be less, and it is adhere to the surface substrate, but it strength will not be as much as your previous, that is HVOF procedure. Then plasma spray. In the plasma spray, the cathode consists of tungsten. You see, this is the cathodes. They are called, this is the cathodes. Cathodes consisting of tungsten rod with a conical tip. You see, this is a conical tip. The tungsten conical tips. Conical tips. About 2% of the thorium oxide we are adding to tungsten to improve it thermionic emission. Thermonic emission will be there. That's why we have to use the 2% thorium oxide. Thorium oxide. Anode is made of copper. This one is anode, this is nozzle portion. Anode is made of copper, copper shaped as nozzle. An insulating block of nylon enclosure as electrodes. Nylon electrodes are insulating materials are used. There we are using water cooled electrodes are intense. This one water cooled will be there. You see, this one will be water cooled portion. It will be to keep it cool, and plasma gas and usually argon. Then here we are using the plasma gas. You see here, this annular paste we are giving the plasma gas. Here we are plasma gas, where it is the insulation, water cooled nylon insulation. This is the nozzle, copper, and this is the electrodes, tungsten, and their powder we are dropping from here. So here a high velocity jet will go. Anode is made of electrodes are intensely water cooled. Plasma gas, usually argon, argon we are using, is used. The nozzle has a port near its edge. The nozzle have a port near its end. You see here the end ports are there where the powder material powder will be feeding. When electric arc is struck between the cathode and anode, electric spark will be there, then combustion, and then high jet velocity around 2 Mach velocity. 2 Mach velocity means sound velocity is how much? 343 meter per second, or 1235 kilometer per hour. With 2 times, around 400, 700, nearly 700 meter per second velocity, the material will go and stuck on the surface coating, electrical surface coating, high temperature, high velocity. So this is also the plasma coating will be there on the surface. That will also one procedure for give a high wearing resistance, and damage mechanical shaft on other portion can be revived with this procedure. Then vacuum plasma spray. This is another part, the sub part of the vacuum plasma spray, but it is doing at low pressure. It is doing at low pressure. Is an advance in the low pressure. You see here it is using low pressure plasma gun, low pressure. Here powder feeding will be there. There so with a it involve melting powder material with high temperature plasma jet and shooting them into a metal or ceramic part inside a sealed low pressure vacuum chamber. The low pressure vacuum chamber, this job was done that inside a low pressure vacuum chamber. That's why it is called vacuum plasma spray, but it is slightly low than the known as low pressure plasma spray. Is an advanced industrial coating technique. It involves melting, so it is also you can use, but it as the pressure is low, so coating adherence to the surface will be not as much as the plasma spray. Similar now, the two-wire electric arc spray. The two-wire electric arc spray is the first thermal coating method that also melt two electrically charged metal wires using an electric arc. Uses compressed gas. You see, this is an electric arc. These two wires feeding the feeding metal, feeding gun, feeding rollers are there. The two wires will come. Here, sparking will be there. Compressed air will come through these nozzles, and then compressed air will be used to spraying the coating, to spray the coating, Then this coating, the wire will melt here, and then coating will go and apply on the surface of the substrate. That is, normally we are doing this type of job on aluminium or zinc based material, where the very high temperature is not required, but melting of the this wire will be melted here, and then the spray will go along with the compressed air and adhere to the surface of the metal. The metal may be the aluminium and zinc. This where electric arc spray methods is being used. So these are the spray methods, spray we are using in industry to safeguard or to revive your damaged mechanical part, which is very costly. Other portion are same, only some portion due to erosion you have to throw it out. You can use this technology, you will get much wear resistance, corrosion resistance, high temperature resistance, and this will be cheaper, and the coating will be much more strength than your parent material. So this technology you can use in are being used in every industry to safeguard or to repair the damaged portion of mechanical parts. Friends, I think if you go through the slides, you will come to know. You will be your concept will be totally clear regarding the mainly three process: high velocity, then plasma, then two wires, and then subdivision of that two. Um, types of thermal coating process we have discussed. And if you are satisfied, and then the difference also we have mentioned. So if you are satisfied, please give a tick mark and subscribe this channel to for your benefit, for your friends benefit. And if you have any doubt, you can talk to me, you can mail me, you can where a video conference can be arranged for better understanding. And you should uh, enhance this channel, because this channel I am going to cover all equipments required for mechanical engineering and instrumentation, sometime in civil also and electrical also required for any industry. So if you read this channel regularly, your knowledge on the industry and in every equipment and every static equipment, rotary equipment will be totally clear. You will be able to face any interview, and you will be able to reply the question being asked to you. Thank you very much.